The first thing we have to define is what is an alphabet. So alphabet is the first thing we have to define because we would like to analyze user input. So the basic thing is an alphabet. That's the set of symbols that the user is allowed to input. We all know what an alphabet is. You might think of the Latin alphabet from A to Z, or the Greek alphabet, alpha, beta, gamma, these things. These are examples of an alphabet. But here in the theory of computing, we have to give a formal definition. And if you think of the letters A to Z, or the Greek letters, or maybe the ASCII set, they are all alphabets, and they have a property, and the only property they actually have is that it's a finite set. So we define the alphabet to be a finite set that's not empty. So we define an alphabet, and usually we use letters like sigma, this is the Greek letter sigma, to denote alphabets, and an alphabet sigma is a finite non-empty set. And actually that's the only requirement that we have for an alphabet. It has to be finite because we don't want the user to input like natural numbers. That would be hard to handle. And on the other hand, empty alphabets don't make sense at all. So that's the definition of an alphabet. Once we have an alphabet, we would like to define what's a word. And if you think about it, what we could use as a definition for a word, and it's simply a sequence of letters. So if we take a sequence of letters, put them together, we'll get a word. And there are no further requirements. So we define a word W to be a sequence A1 to AN is a sequence of letters from an alphabet. Alphabet sigma. This actually very much like the strings, from programming languages like C or Java. They all have strings, and string is the same as a word here in the theory of computing. There's a special word, and that's the empty word, the word that contains no letters. And to actually denote it, we use the Greek letter epsilon. So the empty word is denoted by epsilon. That's also very much like in programming languages. There you have the empty string. Epsilon is more or less the same. Okay, now we have defined what an alphabet is, what a word is, and finally we'd like to define what's a language, formal language. We all know natural languages like English or German or whatever. And in the theory of computing, a language is simply a set of words. And so we define a language. And we say a language is a set, finite or infinite, of words. So a language, L, is a finite or infinite set of words.